Another equation for us to solve. This one has a kind of a different look. It's not an expanded polynomial like we've been seeing before. But we attack it the same way we would any other equation, and we go in looking for common factors before we do anything else. Does this have any common factors? There's an a in this term. There's no free a's in this term. The only thing we have going for us here is that this first term contains a minus 6, and so does this second one. The powers are a little odd, but they do both contain a minus 6, meaning we can pull that out. And we have to pull out the lowest power of it. And between minus 2/3 and 1/3, the lowest power is minus 2/3. So out that comes. And what does that leave us with? From this first term, we get an a, and that's it. Here we get a minus 6 to the minus 2/3 divided by exactly the same thing, so that's gone. In our second term, we get a minus 6 to the power of what? 1/3 minus negative 2/3 is the same as 1/3 plus 2/3, 3/3. Right. So factoring out a minus 2/3 causes the powers of both of these to rise by 2/3. This one rises to 0. This one rises to 3/3. Now, we can clean that up a little bit. We have a plus a minus 6 to the 3/3, which is just the first power, so really we don't need an exponent on that at all. And technically, because it's first power, we don't even need the brackets. We can just dump those. And so now we're at, I'll rewrite that one more time, a minus 6 to the minus 2/3 times a plus a is 2a minus 6 equals 0. Is that all the way factored? It's very close. There's a common factor of 2 here that we should pull out, and I think I will. No sense mostly factoring something if you can completely factor it. Da 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 equals 0. Okay, that's about it for factoring possibilities. So now the zero product theorem says you can take each of these factors separately and set it equal to 0 and try to solve it. 2 equals 0 is never going to happen, so you can skip that part. But we do get a minus 6 to the minus 2/3 equals 0, and we get a minus 3 equals 0. This means 1 over a minus 6 to the 2/3 equals 0. And you've seen a few examples like this already, and you know that these don't produce any solutions. There's no way you can do 1 divided by number and come up with 0. You can do 1 divided by a trillion and get close to 0, but there's no value you can put down here that's going to give you exactly 0. So this turns out to be fruitless as far as roots go. And this one's a pushover. This just means a equals 3. So our only solution to this entire equation is going to be a equals 3.